Hello and welcome to the second section of Unit 11. So again, we're going to be talking about completing the square. We're going to do a little review of completing the square, and then we're going to put an equation from standard form into vertex form by completing the square. So that's kind of what it explains up here. So usually when we complete the square, it's because we can't factor it right away. So the notes we were doing yesterday, you could probably have factored all of those, but normally if you're going to complete the square, you cannot factor. One important thing that you might have noticed or might not have noticed yesterday, when we were completing the square on the notes and all the problems on the assignment, b was always an even number. So that's important. Whenever you have to decide whether or not to complete the square, right here, it's like these two sections were telling you to complete the square, but sometimes you're going to have to decide for yourself. If b is not an even number, you do not want to complete the square. So that's something to keep in mind. So if b is odd, do not complete the square because you're going to get a bunch of messy numbers. So again, here's some steps, but I'm going to skip through those. You can read through those again if you want. So example 1, we're just going to do the same thing that we did yesterday. We're going to solve by completing the square. So first thing we do, I'm going to notice that a is 1, so that's good. So we're going to get rid of c and move it to the other side. So subtract 8 on both sides. So then on the left, we're left with x squared plus 6x, and then on the right, now we have negative 8. So now to figure out what number we want for c, we have to take half of b and then square it. So 3 squared is 9. So that means I'm going to be adding 9 to both sides. So x squared plus 6x plus 9, negative 8 plus 9 is 1, so equals 1. So now on the left, I should have a perfect square. So half of 6 is 3 and the square root of 9 is 3. So x plus 3 squared equals 1. Take the square root on both sides. And then we get x plus 3 is equal to plus or minus, don't forget that plus or minus, the square root of 1, which is just 1. Then subtract 3 on both sides. So x is equal to negative 3 plus or minus 1. Again, these are both whole numbers, so I can combine those. So I'll take it a step further. So x equals negative 3 plus 1, and x equals negative 3 minus 1. So our two x values will be negative 2 and negative 4. Example 2, so again we're solving by completing the square. So this one's a little bit different. So we start with the c value on the left and the b value on the right. So we need to flip those, we need to reverse that, because we want the x squared and the x to both be on the left side, and we want the c to be on the right side. So first thing I'll do is add 12x to both sides. So x squared plus 12x plus 19 is equal to 0. So now it looks a little bit more familiar. So now again, we're just going to start with our first step, subtracting c, or moving c to the other side, so subtracting 19. So then x squared plus 12x equals negative 19 is what we'll be left with. Now we got to take half of b and square it. So 6 squared is 36. So that means I'm going to be adding 36 on both sides. So on the left, we'll have x squared plus 12x plus 36. And then on the right, negative 19 plus 36 is 17. So the left side should be a perfect square. So if you take half of b, you get 6. Square root of c is also 6. So that means I'll have x plus 6 squared equals 17. So remember, this sign is always the same as this one. So to get rid of the squared and solve for x, I got to take the square root of both sides. Oops. So x plus 6 will equal the square root of 17, but notice I forgot to do something. Got to do plus or minus whenever you take the square root. So subtract 6 on both sides. So x is equal to negative 6 plus or minus the square root of 17. So this time we cannot take the square root of 17 and get a whole number. So I am just going to leave my answer just like that, and we're done. So example 3, this time we're going to find the vertex by completing the square. So it's pretty similar to what we're going to do. So first thing I'm going to do is I'm going to subtract c. I'm going to subtract 10 on both sides. So now on the left I have y minus 10. On the right I have x squared plus 4x. So the side that has x squared and x, I'm still trying to complete the square. So I have to figure out what number I can put for c to make this a perfect square. So I take half of b, so 4 divided by 2 is 2, and then I square that number. So 2 squared is 4. So that means I need to add 4 to both sides. So far it's pretty much the same thing, just we have a y here instead of 0, so it's a little bit different, but we're doing the same things. So negative 10 plus 4 is negative 6, so y minus 6 equals x squared plus 4x plus 4. So now on the right side this time I have a perfect square. So half of 4 is 2, and the square root of 4 is also 2, so I'm going to have x plus 2 squared. So this is where things get different. Since I'm not trying to solve for x, I'm trying to find the vertex only. I want this to be in vertex form. This is really close to vertex form. So remember, vertex form looks like this up here. So we have something squared in parentheses, and then plus or minus some number equals 0. Or in this case, it's going to equal y. So all I need to do is get this 6 to be on this side, because I just want y by itself. So if I add 6 to both sides, I end up with y is equal to x plus 2 squared, and then plus 6. So now it's in vertex form. So once it's in vertex form, it's easy to find the vertex. So the x value is this number with a different sign, so negative 2, and then the y value is right here, so 6. And that's the vertex. So that's how you find the vertex by completing the square. So it's almost the same thing as when you're solving for x by completing the square. It's just you don't have to do as much work. So moving on to the next page, we're going to find the vertex by completing the square. So same thing that we just did. First thing I want to do is get rid of c. So subtract 15 on both sides. So x squared plus 10x equals negative 15. Take half of b and square it. That's the number you're going to add to both sides. So plus 25 plus 25. So x squared plus 10x. Oops. Just 10x, not x squared. Plus 25 is equal to negative 15 plus 25 is 10, equal to 10. So now here on the left we have a perfect square. So half of 10 is 5 and square root of 25 is also 5. So x plus 5 squared equals 10. So again, I'm finding the vertex, not solving. So I want to put it in vertex form. So that means that this side will either be y, or f of x, or it'll be 0. So I have to get rid of this 10. So I'm going to subtract 10 on both sides. So x plus 5 squared minus 10 equals 0. So now it's pretty easy to see that the vertex is this number with the opposite sign. So negative 5, comma negative 10. So I like finding the vertex this way because you don't have to do as much work as opposed to solving. So like number 5, it says solve the equation. So the a is still 1, So first thing I'm going to do is get rid of c, so subtract 20 on both sides. So x squared plus 6x is equal to negative 20. Take half of b and square it. So that's the number I'm adding to both sides. So x squared, so I'm adding 9 to both sides. X squared plus 6x plus 9 equals negative 20 plus 9 is negative 11. On the left we have a perfect square. So x plus 3 squared is equal to negative 11. Take the square root because, again, we're solving. So we got to get x by itself. So that means we got to get rid of the squared. So x plus 3 is equal to plus or minus the square root of negative 11. So, well, we can subtract 3 on both sides, and we get x is equal to negative 3 plus or minus the square root of negative 11. So notice we have a negative number inside of a square root. As of right now, we cannot do that. We cannot take the square root of a negative number, so we cannot get a real answer. So our answer that we're going to put is no real solutions. Pretty soon we're going to learn how to solve things with negatives inside of the square root, but as of this point we do not know how to do that, so it's just no real solution. And then our last example, I'm just going to say find the vertex instead of solving. So this time a is not 1, it's 4. But I can see right away that all 4 of these numbers are divisible by 4. So you can either factor out 4 or you can divide everything by 4. So then we get x squared minus 10x plus 14 is equal to 0. So now it looks a little bit more conventional. So get rid of c. So x squared minus 10x is equal to negative 14. Now I got to figure out what c value I need for a perfect square. So take half of b and then square that number. So 25 is the magic number that I need to add to both sides. So x squared minus 10x plus 25 will be on the left now. Negative 14 plus 25 is 11. So on the left we should have a perfect square. Half of 10 is 5. Square root of 25 is 5. This sign's minus, so I'm going to have minus in here. So x minus 5 squared equals 11. So I'm just finding the vertex, so I don't want to take the square root. I want to put it in vertex form. So that means I need this to either be 0 or y, or f of x. So I'd get rid of that number by subtracting 11 on both sides. And then I get x minus 5 squared minus 11 equals 0. So to find the vertex, now that it's in vertex form, take this number, change its sign. So that's your x value, and that's your y. So as you can see, once you get into vertex form, it's really easy to find the vertex. So that's why we are completing the square to put it in this form, to make it easy, to make it easy on ourselves. And that's it for the notes.